All right, good morning, guys. Today we're going to be covering 7.1 radicals and quadratic equations. So let's go ahead and jump right in and see how we're doing with them. So first off, we're going to simplify radical 48. And there's some steps that we need to take in order to simplify this, but they're pretty straightforward. So the first thing that we're going to do is we're going to go ahead and create a factor tree of 48. So we're going to break it down into all the prime numbers that will multiply to be 48. And again, prime numbers are numbers that can only be divided by 1 and themselves. So breaking down 48, we'd have 24 times 2, and then we can break down 24 into 12 times 2. We can break down 12 into 3 times 4, and we can break down 4 into 2 times 2. So now we have all these prime numbers. And if I were to multiply them, 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48. So we get right back up there. Now from here, we're going to go ahead and write out all the prime numbers under the same radical. When we do that, we want to circle the pairs. So writing this all out, we have 3 times 2 times 2 times 2 times 2. Again, that's just all these numbers that we circled. Again, we have a pair of 2's here. A pair is just 2 numbers. Like I have a pair of socks. And then we have a second pair as well. So I take both of these pairs outside. Now it's important to remember that this is all multiplication. So don't forget that it's all multiplication. We're only taking one number from each pair. So this will leave us with 2 times 2 radical 3. Of course, at this point, and the 3 didn't have a pair, so it just stays inside. It doesn't get to go anywhere. From this point, we just go ahead and we simplify. This is, again, all multiplication. So 2 times 2 would give us 4. So our final answer is 4 radical 3. All right, next up, we're going to simplify radical 18 plus radical 32 plus radical 75. Looking at this, the first thing that we need to do is we need to break these all down into the prime factors. So we want all the numbers as prime numbers in their factor trees. So for 18, I can break it down into 9 times 2. I can break 9 down into 3 times 3. For 32, I can break it down into 16 times 2. 16 is a perfect square, so I can break that down into 4 times 4. These are not prime numbers, but they're a pair. So if I run into a pair while I'm breaking it down, I can just stop at that pair, because I know that once I have a pair, those can go outside the radical. Lastly, for radical 75, that breaks down into 25 times 3, and 25 breaks down into 5 times 5. So from here, we have all of our prime numbers all written out. And so we put them underneath radicals. Again, if we have a pair, they can leave the radical. We have a pair of 3's, a pair of 4's, and a pair of 5's. So they all leave. So we're left with finally 3 rad 2 plus 4 rad 2 plus 5 rad 3. Now, if they have the same number underneath the radical, meaning 2 and 2, then I can add the numbers in front of the radicals. So therefore I have 3 plus 4 radical 2, which is the same as 7 rad 2. And then the 5 rad 3, well, that doesn't have any common radicals, so I just bring it on down. So our final answer is 7 rad 2 plus 5 rad 3. Next, we have simplify by rationalizing the denominator. Now this is useful once you guys get into complex numbers, complex equations and complex numbers, as well as imaginary numbers, which are just I. So it's important once you get here because it's extremely useful for us to be able to get rid of these imaginary numbers when we're trying to solve. So with rationalizing, and that's the only reason that we really do this, because they tell us that we can't have a radical in our denominator. And the reason for that, it goes back to dealing with imaginary numbers and complex numbers. So this is just to prepare you guys for a future lesson that you'll need in a couple years. It's just so that to familiarize you guys with this. So to rationalize rewrite the fraction so both numerator and denominator have a square root. So if the entire thing is the square root, then I can break this down and say that it's equal to radical 5 over radical 3. From here, get rid of the denominator's radical by multiplying both the numerator and denominator by the denominator. So this says that we cannot have a radical in our denominator. So I'm going to multiply both the top and bottom by radical 3. What that does is it will cancel out the radicals on the bottom, because rad 3 times rad 3 is just 3. So I'll just go ahead and show multiplication here. And again, it's important to note that we're multiplying by radical 3 over itself, which is just equal to 1. So we're not changing anything in our equation. We're just essentially multiplying by 1. So when we multiply by 1, we'll be left with radical 5 times 3. There we go. So we'll be left with radical 5 times 3 over radical 3 times 3. Oh, we have a pair of 3's. Let's go ahead and take those out. And our final answer will be radical 15 over positive 3. And that's how you can rationalize. Always multiply by the denominator over itself when you need to get rid of the radical in the denominator. All right, next up, solve for x. We have x squared plus 9 equals 25. So to solve for this, the first thing that we would do is we'd subtract 9 from both sides, giving us x squared equals 16. From here, to get rid of the square, we take the square root of both sides. That gives us x equals plus or minus 4. The reason that's plus or minus is because positive 4 times positive 4 equals positive 16, and negative 4 times negative 4 also equals positive 16. All right, the last one that we'll deal with radicals is this. Solve for 3 rad 5 squared plus 3 rad 2 squared equals x squared. So this looks like a Pythagorean theorem type problem, right? A squared plus b squared equals c squared. So let's go ahead and solve this. When I'm squaring, the square goes to both the number on the outside of the radical and to the radical itself. So this would give me 9 times 5 plus 9 times 2 equals x squared. Again, 3 squared is 9, and then the square root and the square cancel each other out on both of these, giving us just positive 5 and positive 2. 9 times 5 is 45, and 9 times 2 is 18. Adding 45 and 18 together will get us 63, which is equal to x squared. Lastly, to get rid of the square, we take the square root of both sides, giving us x is equal to radical 63. Now, I want to break this down and try and simplify my radical again. So I break it down into 9 times 7. And I can break 9 down into 3 times 3. Oh, we have a pair of 3's. Therefore, our final answer is 3 radical 7. Of course, plus or minus since we're dealing with algebra right now. All right, next up, let's talk about quadratics. Quadratics and factoring. So I'm just going to go through 2 examples of this. The first one is the pitchfork method. So step 1, make the function into standard form, ax squared plus bx plus c equals 0. As we look here, we have ax squared, we have bx, but our c value is missing and it's not equal to 0. So the first thing that I'll do is I'll add 16 to both sides to get it into standard form, the form that we were just looking at. At this point, I'm going to take my a value and multiply it by my c value. That's why it's called the pitchfork. That will, of course, give me 16. Now, typically you don't need to do that step if your a value is 1, but if it's a different number, it's essential that you do that. From here, I'm going to go ahead and I'm going to find numbers that add to be our b value, negative 10, and multiply to be our c value, positive 16. So I write out all the numbers that multiply to be 16, 1 and 16, 2 and 8, 4 and 4, and then all the negatives as well. The only one that will add to be negative 10 is -2 and -8. So at this point, I'm going to go ahead and I write my double bubbles up. And the first thing that goes into both bubbles is the variable that we're dealing with, x. The second thing that goes into both bubbles are the values that we just found, -2 and -8. So we have x minus 2 times x minus 8 equals 0. From here, each parentheses will get its own equation. So we have x minus 2 equals 0 and x minus 8 equals 0. At this point, we just go ahead and solve. We get x equals +2 as one answer, and x equals +8 as our other. All right, the next method that we'll go through is to factor by grouping. This time we have x squared minus 8x plus 15 equals 0. So first, break the b value into two numbers that multiply to be c. So we have our b value here, -8. What numbers can I break this into to multiply to be 15, +15? Well, what about -5 and -3? So I rewrite it out, x squared minus 3x minus 5x, again, those are just from the broken -8x, plus 15 equals 0. Next, we group up. I group my first two terms together, and I group my last two terms together. So I have x squared and -3x grouped, the first two terms, -5x and 15 grouped, my last two terms. From here, we're going to go ahead and factor out the greatest common factor from both groups. So we're going to find that GCF, the greatest common factor. The GCF of our first parentheses is just x, so I factor that out. And the GCF of our second parentheses is -5. Now, if I can factor out a negative, do it. We know that we're on the right track if the things that are left, the terms that are left within our parentheses are the same. So at this point, now that we are on the right track because we factored out correctly, we're going to go ahead and we're going to group up again. This time, I'm grouping up anything that is on the outside of the parentheses, that gets its own parentheses, and I'm also grouping up and combining my parentheses that we currently have, x minus 3 and x minus 3. So give me x minus 5 times x minus 3 equals 0. Oh, it's factored. Now I can set up my two equations. So I have x minus 5 equals 0, and I have x minus 3 equals 0. Solving for x, we get x equals 5, and we also get x equals +3. Now that's how we can factor by grouping. So now there are two methods that you can use. Thank you guys so much for watching. If you have any questions, please let me know, but have a great rest of your day.